All right, so my name's Ryan Krueger. I work with EnerChange. I'm going to go through the lighting basics and kind of give you the lens needed to address certain applications within your building. There's a lot of history built into electric light, and then the transition to LED kind of changed the entire landscape where the running joke has always been how many people does it take to screw in a light bulb? And as we push towards LED, it seems like there's more and more people required. Um, so my background, I've spent the last 10 years in energy efficiency. Most of that was focused on lighting. I've screwed in a lot of light bulbs through different Excel programs. And then I kind of pivoted and moved towards outside sales of lighting. And so through outside sales, it's like I'd get dropped into an application, have to figure out what the existing system is, and then provide. In some cases, it was a non-LED upgrade where it's like, all right, the best application is not LED in this scenario. I guess people are trickling in, but yeah, it's just an interesting game where lighting is everywhere, and I can't really like flip that switch off when I find bad lighting. And it's like the implementation of LED has brought a good amount of applications where we need to go back and redo that lighting. Um, so I'm going to cover the basics. So I'm going to go through types of bulbs, different sockets, Kelvin temperature, foot candles, lumens, and then how all of that applies to LED, and then a couple different real world applications like converting a church sanctuary to LED. Say you have a school attached to your church, there's different retrofit options for your gym fixtures, whether that be high bays or new fixtures. And I'll go through what the number breakdown of both of those looks like. And then briefly touch on exterior. So it's generally wall packs, but I can show good versus bad. And then I have a couple slides of bad lighting that in one instance it made it into the local news because of the very specific like problem with the LEDs. Shameless plug for the training certifications that I have through the organization that I used to work for. So, LS1 is Lighting Specialist 1. So, through this certification, it's an introduction to lighting, the different light sources, how to transition to LED. It's self-paced 1 to 4 months, and the training modules are online. So you go through sections 1, 2, 3, and then you'll take that knowledge base to the field where you're looking at 4 foot troughers and different applications and like matching the knowledge base that you just learned to the actual field. And like that's how I learn best. I'm a lot better at looking at something, figuring out how it works, and then going and figuring out what the actual science behind it is. The class is $400 for anyone on this call that's like a volunteer facility manager or a facility manager, or they work within their building. Having a good grasp of how the facility is lit is very beneficial. There's a second course that kind of compounds all that information from LS1 into LS2. So it's a deeper dive into LED and different techniques, and there's lighting layouts that you can move into, and there's certain city municipalities that have specific like lighting layouts that you need to have them pre-qualify before you can even start on a project. It also goes through calculating the energy savings, projecting budgets, what type of light levels you need in certain applications. And then there's code, and this is also self-paced. It's a little more geared towards someone specifically selling lighting. There's a good chunk of this that's like how to connect with the top to get your project implemented. All right, so types of bulbs. There are so many types of bulbs, and the image on the right is just screw-ins. But as you go through, starts with A15s. A19 is the standard screw-in light bulb that you basically see everywhere. You can go up in size to A21 and then A23, and that's just A series. B series, you're looking at candelabras and more decorative. C series, similar game. G is globes. So, like in dressing rooms, you'll see 25 G25s around the mirror and then kind of up in size. But then there's BR, there's R series, there's PAR, and then the T series. So, the T series is tubes, T8s, T5s, T12s. On the BR, that's more directional. So with these, they're screwed into applications where you see them a lot in sanctuaries or recess cans where you need a certain light level, a certain size bulb to fit into that housing, and then a specific beam angle that is throwing. So like the BR30 comes in a 15-degree beam angle, a 30-degree, a 45, and a 60. So if you needed a 60 and you got a 15 and you're relighting a Narthex, you're going to have different like spots where there's no light. Whereas if you did a 45-degree beam angle, you eliminate that dark patch. But then and that's just screw-ins. And then on the like there's metal halide of 250 watt, 400 watt, 1,000 watt. Then there's high and low pressure sodium, incandescent, mercury vapor, induction. There's fluorescent lighting, and then you get to LED. And like basically from front to back, you're running 130 years of technological advancements within the electrical field. And so as each one of these technologies phased it out, there was new technology. So like for instance, induction lighting, I've sold a couple induction bulbs in applications where induction lamps have 100,000 like lifespan. LEDs in most cases are 50 to 70,000 hours. So the induction lamp was cheaper and would provide the same light levels. And I thought, I'm never going to be in another application where I can sell someone induction. So I did it. And like we sourced the material. There was one distributor in California that had 10 of them on hand, and we're like, we'll take them. But, and then as far as fluorescent, it's like fluorescent also got implemented across the board on a lot of these different types of bulbs. And then LED covers the whole spectrum. And like this next slide is sockets. So there are lots of different socket types. It's like just for screw bases. So the E39 is your standard mogul base. So on that mogul base, that's going to be the 400 watt metal halides, the 1,000 watt metal halides, or it's just a bigger socket. And then your standard A19 socket is the E26. And then, like in ceiling fans, they have an E11 base with a candelabra bulb. But for some ceiling fans, they actually have an E14 screw base. So it was a loophole that the fan industry was able to capitalize on when they mandated LED for those fans. They switched socket types, and then you have an E14, which is technically a medium socket, but like you don't necessarily know that until you literally unscrew it, look at it, and go, why is this a different size than what I bought? And then the biggest thing is fluorescent pin bases. So there's mini bi-pin, there's recess DC, there's 4 pins, there's 2 pin, Sometimes the bulbs are horizontally mounted, sometimes they're vertically mounted, and then you get into kind of the more specialty applications that are bipins of G4 and GU4 and G12, where you're not necessarily going to know that that's the socket type until you pull it out, look at the nomenclature, and then have the exact socket type. Because if you're retrofitting fixtures, you're using that existing housing. So making sure that you get the socket type right is very beneficial. And then the next building block is Kelvin temperature, also referred to as color temperature, also referred to as correlated color temperature. So it's three different titles, all that technically mean the same thing. When you climb down the rabbit hole of Kelvin temperature and then you click on, like through Wikipedia, if you click on it, you get to color. And then you get in the rabbit hole of what is color, where it's like the science just gets kind of crazy, where it's like I pulled the definition of CCT, and it's the temperature of the Planckian radiator whose perceived color most closely resembles that of a given stimulus at the same brightness and under specific viewing conditions. That doesn't necessarily mean anything. For the most part, like with clients, it's did I match the Kelvin temperature? Do they want a lower Kelvin temperature? And then like the actual definition is color temperature is a way to describe the light appearance provided by a light bulb. It is measured in degrees of Kelvin on a scale of 1,000 to 10,000. So like a candle is 1900, high pressure sodium is 2200, warm white halogen and incandescent are between 2,700 and 3,000, and then natural white metal halide 4,000 to 5,000. They say the direct sun is 4,800, but it really depends on which scientists you listen to. Some people say that it's 10,000, like the blue sky on the far right, but then day white is 5,000 to 6,000, and then cool white 7,000 to 7,500. But like within lighting, fluorescent is going to be offered between 2,700 Kelvin and 6,500 Kelvin. And it's just kind of a game of matching that existing color temperature. And in church sanctuaries, you have to get it right. It's like there's not, if all of a sudden everything in there is their specific color temperatures and you change it all to 5,000 K, you're going to get yelled at, and then you're going to have to redo everything. And so this is an application I was at last week where I'm in a mechanical room. They have 8-foot strip fixtures, two different bulb types. So this leads me to believe that their maintenance guy was told we need light bulbs. He goes to Menards, buys Byte electric tubes that are 6,500K. And like I walked in and was like, wow, these are super blue. And the first fixtures that I was looking at weren't open. And then I wandered back into the mechanic room and I was like, oh, okay. These are 65K. The Phillips tube on the left is 4,100. And it's like, it might just be I, like my nitpickiness where I prefer the Kelvin temperature to be consistent across the board. There are certain applications where you do multiple different Kelvin temperatures to try and elicit circadian rhythm to enhance students' ability to learn, but those are very niche applications where yes, they intentionally did it, but this is not an application where that was intentional. But like when you're looking at a bulb type, or I guess whatever you're replacing, there's always nomenclature on either the end cap or the socket where you can get a good idea of, like on the fight tube, it says F32T8 965. That 65 indicates 6,500 Kelvin. That 32 indicates 32 watts. Foot candles. So this is the metric for actually knowing how much light is hitting the ground. So the technical definition is a foot candle is a SI unit of illuminance or light intensity. The foot candle is defined as 1 lumen per square foot. This unit is commonly used in lighting layouts in parts of the world where United States customary units are used. But 1 foot candle equals 10 lumens. One candle, like a literal, like if you light a candle on your bedside table, that's 1 lumen. If you go outside on a full moon and you have clear sky, a full moon is 1 foot candle. In your bedroom when you're reading, ideally, or your lamp is generally 10 to 15 foot candles. But so the graph, or the I guess the table on the left, kind of covers um, what you should shoot for. It's like there's the Illuminating Engineering Society that puts out this information that says this building type, this type of space, this is the recommended foot candles. So like for a warehouse, larger items, 10-foot candles, smaller items that are lower to the ground, you want 30-foot candles. Offices, 40, break rooms, 15, bathrooms, 18. On the very macro level, at like a hockey arena, for collegiate hockey to be broadcast on TV, you need 100-foot candles. For professional hockey, they require 200-foot candles. So if you're looking at that of like, all right, one fixture is rated for X amount of, it'll be lumens, and I'll go into it on the next slide, but like you'll need a fixture that's twice as powerful to reach that same like designated foot candle level. But like when I'm going through, I have a sensor that allows me to know exactly what the foot candles are. It's like in a lot of applications, you end up in a church sanctuary where they have skylights and you hit it on a Tuesday at 10 a.m. where the sun is completely overhead, and you take your reading and it says 75, but you know that that is not actually what it is. So it's just kind of a game of getting my initial numbers and knowing like where I'm gonna need to do some magic, I guess. Which brings to lumens. So lumen is the unit of luminous flux, a measure of the perceived power of visible light emitted by a source in SI units. So light source, say it's 10,000 lumens, you're 10 feet from the light source. The um, the foot candles would be 127.3, which is significantly high. But in this application, you're realistically looking at a fixture that's mounted 20 feet in the air. Whereas once that fixture's that high in the ceiling, at 10 feet, way too much lumens. But at the floor, you're at 30-foot candles, which is realistically perfect for the application you're working with. Um, and on like fixture spec sheets, it generally tells you what the lumens are. And like if you're redoing a gym and you know what the existing 4-foot T8 tube fixtures are, you can backtrack the math to know exactly what you need. And like this image on the left is just a general rule of thumb where it's if it's between 10 and 20 feet, you need 12,000 to 21,000 lumens. You go up another 10 feet, 22,000 to 35,000. At 30 to 40 feet, you're looking at 35 to 47. 40 feet, 47,000 lumens. In certain applications, they may want more lumens. I did lighting in a machine shop where what I had originally spec'd was 20,000 lumen fixtures. They wanted increased brightness. We went up to 35,000 lumens, installed that. looked fantastic. Originally on paper, I'm like, I think this is going to be too much. But then once it was physically installed, the the machine shop floor looked amazing. Granted, they had to do some cleaning because it kind of highlights where it might be a little grungy, but like that's kind of the game you play. Um, okay, so I'll actually physically go through a spec sheet because that's kind of the game. It's like, all right, I need this thing. There's lots of things. It's like Keystone has just on here 10 different subcategories of LED tubes, and then each one comes in different Kelvin temperatures and all the way down. But like when you're physically looking at the spec sheet, it breaks down the 3 or 4 different metrics that I just kind of went through. It's full screen. Ah, the share your screen icon is in the way. Oh, there we go. Okay. This website was a little slow when I was on it earlier, but lots of different tubes. Oh, so literally right here, 15 watt, 2200 lumens per tube. It's color selectable, single ended and double ended. So wiring is easy for the electrician. But on the spec sheet, so like when I submit a rebate to the utility, they require that I provide them an invoice and they require the spec sheets for the product that was installed. And so there's different certifications through different governing bodies that provide you a higher rebate. So, like on a product that doesn't have a DLC certification, it qualifies for the minimum rebate through XL for a tube. So, say it's not DLC certified, it may only qualify for $1.75 per tube, whereas that DLC certified tube may qualify for a $3 rebate. And there's just certain applications where it's it just maximizes what your rebate dollar value is. But lamp type, it's a 4-foot linear tube. Bulb type, it's a T8 LED. The base, which is a medium bipin, is the G13. Wattage is 15 watts. Um, this specific tube is color selectable. So if you don't know what the existing Kelvin temperature is, or you're not 100% sure, or everything in the building is a different Kelvin temperature, you can buy this tube, switch the dongle to the color that you want, and then rinse and repeat across the entire building. So in like, and I've had applications where the one section needs to be 3K, one section needs to be 5K. Some of the 5K gets mixed into the 3K, and it's like, all right, now we need to send an electrician back in. They need to get a lift, get up in the air, swap them out. Whereas this eliminates kind of the rigmarole. And then kind of as you go through, it's like the input voltage is something that you'll need to know on the electrical panel. It'll be able to it'll tell you where it's 120 volt to 277 volt universal. So it'll work between that. It'll work on 208 or 240. And um, if odd chance you're running 480, this won't work. And then the application, you need to find fixtures that only run 480, which generally you're working in like explosion proof fixtures and it gets pretty complicated. But the power consumption is still 15 watts. On this, it's referred to as CCT instead of Kelvin temperature, which that's just why knowing all three is helpful. But the lumen output slightly changes depending on what the Kelvin temperature is. So granted, it's not a lot, but in certain applications, it might be prevalent. But then how they determine the efficiency of LED for the last, I guess, 10 years has been lumens per watt. And so the higher you go in lumens per watt, the brighter the fixture is and the lower the wattage is. And like right now, I think TCP was able to hit 210 lumens per watt, so you can get a lower wattage fixture with the same light output and drop 10 to 15 watts, just kind of depends on the application. But then beam angle. This comes into play pretty significantly for schools where you have pendant fixtures that are providing up and down light. So a fluorescent tube is going to throw light in a 360-degree angle, whereas a 4-foot LED tube has a strip of diodes running on the top of the tube. So you only get 240 degrees of light output down. And then if you install those tubes all across the board in pendant fixtures, that uplight's no longer there. So it kind of creates a cave effect. And then lifetime. So it's expected to run for 50,000 hours. So if you backtrack that math, it's they can run 24 hours a day for 6 years. What's nice about Keystone is that they have wiring diagrams. So if you had someone on your team that has a decent understanding of how the building is wired, and you say, here's 10 cases of tubes, go install them. Here is the wiring diagram. I don't necessarily need to get into this, but there's tubes that can run on your existing ballast, or there's tubes that require being rewired. And instead of running the line voltage to the ballast, it's running to the end cap and it's running through the lamp holder. And there's 3 different iterations of them, and I never 100% figured out non-shunted versus shunted. I just let the electricians do their thing. But having that information easily available is very helpful. I'm going to also go through actual fixture. So there's wall packs. There's all sorts of different types of wall packs. They're for exterior. I don't know why this website's slow. But essentially same thing. On exterior fixtures, they'll give you what the distribution pattern is. So kind of same game where here's the wattage. It's 120, 277 universal. This also has a color temperature toggle where it can go from 4,000 to 5,000 K. It gives you kind of what the wide optic lens looks like. There are 5 or 6 different light distribution types that each exterior fixture can do. So it's like this specific fixture is going to throw light in this manner, where if you're doing the outside of a building and you need to light the sidewalk that's, say it's 40 feet away, this is going to cover it. And then building diagram and kind of what you're going to need to get the system operational. It's like there's photo cells and different wiring to kind of connect it to the time clock. But that's kind of how to read a spec sheet, because like all of the information that I covered goes into this, and then if you start looking at it, it might not mean anything. Okay, so this brings me to light emitting diodes. So a lighting light emitting diode is a semiconductor device that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. The color of the light corresponding to the energy of the photons is determined by the energy required for the electrons to move the band gap of the semiconductor, which is technically a PN junction where electricity comes in, it hits the PN junction, it gets scattered, and then there's two different elements that kind of change that color. So, like to create purple, you need a specific bandwidth to cover that. And the last 6 slides of basics that I've covered span 100 years of lighting. So it's like LEDs kind of the fix all, but you're replacing older systems. And all of the I don't want to say all, but a lot of them come in all of the different bulbs and socket types that I covered in slides 3, 4, and 5. So it's like if you have an oddball socket type in a weird recessed fixture, if you pull that bulb out, take a picture of the socket, send it to a lighting distributor, they'll say, hey, you need this product, here you go. And that's about as easy as you can make it. But US Bank Stadium. So I was fortunate enough to do a tour of this building a couple weeks ago. They have probably 500 1,000-watt LED fixtures that are mounted on that second deck that light the field. And then along this whole portion here and this top section are color changing fixtures that you can tune to whatever color you want. It's currently set to purple for the Vikings, but that lighting system, very intricate, all controlled. You can hop on a computer, change the color, do whatever you want. And like at the same time, like this was done by Gopher Stage Lighting. They're a small organization out of St. Paul that has done basically every color changing fixture in the Minneapolis skyline. So like the 35W bridge is blue, the Hiawatha bridge is blue. They also did the new Raiders stadium where it's like that is a beautiful brand new building that you can change the color to whatever you want. And that's kind of where LED meets like the new age of technology where it's basically a computer, and if you hook up the system correctly, you can make it dance. All right, so real world application 1, so church sanctuary. So when I first got started in lighting, I got dropped into church sanctuaries. I didn't realize that this was going to be the most difficult application, and it was a really good learning curve. It's like you have the pendants that are in the top that are screw-in incandescent bulbs. You have the bulbs that are along this that are 250 watt par 56s, and then somewhere else in here you'd find 4 500 watt quartz halogens. So like each one of those is a specific Kelvin temperature, and you basically need to get it right. And at the same time, like you're 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 updating a lighting system that could be 75 years old. And like these pendants are beautiful and usually insured for a high dollar value. So it's getting it right on the first go. So this is kind of the breakdown of how my brain actually like turns a project into a workbook into the estimated savings. And now run hours are key. So on this left side, this is based on 10 hours a week for 52 weeks. So it's 520 hours a year. If I doubled those run hours, I would cut my payback in half just because the system is being used significantly more. But so Sanctuary 1, run hours, 520 hours. The quantity is 12. The lamps per fixture is 1. It's par 56, 2700 Kelvin. Currently using 250 watts. Total watts It's 3,000 across the 12, and that total kWh consumption is 1560. You multiply that 1560 by 16 cents, and then you have your annual cost to run those fixtures. So you're looking at, call it $600-700 to run the existing sanctuary. You convert that to the LED versions of those existing bulbs. So the run hours are still the same, quantities are the same, fixture type same, LED replacement different. So those wattages change. So you go from a 250 watt par 56 to an LED par 56 that's 40 watts. In the quartz halogens, you go from 500 watts to 100 watts. On the pendants, you go from 60 watts to 5 watts. So your kWh consumption pretty drastically drops, and you go from using $600-700 to $80. And so I did ballpark material costs just from one of the local distributors' websites, where materials roughly $3,000. CEE has custom rebates that'll cover 25%. That'll cover $737. The total cost is $2,200. The kWh reduction is $3,000. So your estimated annual savings is $480. So your payback is 4.5 years. And like when I'm dealing with church sanctuaries, and I guess like churches on our client bases, a lot of them have a board of directors where they want this information. They want it easily palatable. They want it to be explained in a manner that says, all right, these are the numbers. Are we going forward with this? Yes, no. Okay, so a real world application of a gym retrofit. One of the biggest things that you need to know is, or I guess before you start anything on a lighting project, is how is the space being used? What foot candles do you need? How high is the ceiling? What is the existing Kelvin temperature? What are the existing fixtures? How many are there? What is the current foot candle reading? So like as you go in, you just kind of want to know, all right, what's the space being used for? How much light do we need? What is going to be the replacement opportunity? Um, and again, run hours are key for a lot of the congregations we're working with. Their congregation is reduced in size, so there's less run hours. But given the application of, say, it's a school where it's running 6 hours a day for 260 days a year, you're looking at 2,080 run hours. So the payback's significantly faster. So for 54 lamp fixtures, they're 4 lamp um, T8 tubes that are 5,000 Kelvin, 32 watts apiece, 6,400 watts total, but that total kilowatt hour consumption is 13,000. So the annual cost to run those fixtures is roughly $2,100. If you convert those 4-foot tubes to 4-foot LED tubes, run hours are the same, quantity lamps same, Kelvin temperature same. The kWh consumption drops to 74.88. Your annual cost drops by 1,000, and then ballpark retrofit pricing at $10 a tube, you're looking at $2,000 in material, a prescriptive rebate through XL that's just based on one tube replaced with a new LED tube, so that rebate is 1,200. So that total cost to retrofit is $800. The kWh reduction is 58.24. Estimated annual savings is 931.84. So your payback is 9 months. So the cost of retrofitting versus new fixtures is very apparent here. So if you were to convert these fixtures to, say, 110 watt LED high bay, the numbers change drastically, where you're not, to get the same light level that the system is putting out now, you're still going to be using a similar amount of kWh. So like 20 fixtures or 50 fixtures, 4 lamps, they're 4 lamp high bays. The kWh consumption is the same, the cost is the same, but with new fixtures versus retrofit is generally 2 to 3 times more expensive. So 110 watts, kWh consumption is 11,440, and then annual cost is 1830. Material cost ballparked at $150 per fixture. Your material cost is 7,500. Your prescriptive rebate is significantly better. So that prescriptive rebate for new fixtures is 2 to 3 times better than a tube rebate, but that total cost is still $3,000. So the kWh reduction is 1872. Your energy savings is $300 a year, and that payback is 10 years. So in scenarios where I was asked to bid out um, retrofit versus new fixtures, I just provide both proposals. And if the idea is they want to improve the aesthetic and go with a new fixture, sure, go that route. If the idea is to save energy and save a significant amount of money with a quick payback, is like certain industries require a 2 year payback. Otherwise, they're not going to look at the project. All right, bad lighting. So it's everywhere. I have light sensitivity. I wear contacts. If I'm driving around at night, LED headlights are a problem because I'm in a sedan and most people are in SUVs or trucks. So it's just, I'm like hiding from all of my mirrors. But it's a game of the diodes are exposed. The fixture is at an angle where it is throwing light up and not specifically down. And like this image kind of hammers it home where it's like if you have a fixture that does not have the diodes exposed and it's just throwing light at the ground, then you reduce light pollution. And like right now, there's a lot of talk in the lighting industry of dark sky compliance and um, just dark sky in general. It's like they're creating new national parks around um, like dark sky places where you have a full view of the Milky Way. Whereas like if you've ever driven from Denver back to Minnesota, when you're on 35 and it's dark, there is a haze around the entire like metro area, and that's all just light pollution. Um, LED wall packs. So this specific wall pack, they're all over the place. They throw light farther than it needs to be thrown. When you look at it while you're standing outside of the building, you see that the light is throwing up. They every for most fixtures that you buy, they'll give you the light distribution pattern. So like you can see that like the concentrated light that you need is here. It's mounted at 15 feet. So basically you just need this section. Because like once you're this far out, it's not it's not adding enough light for you to be able to like read or like do what you're supposed to be doing with lighting, but the solution is this. So the lighting distribution pattern from here to here at the same mounting height covers the same amount of light. So you can just, instead of doing a wall pack, do a cutoff. You can go up in wattage to have it throw farther out if you need to, but this is exactly the application where if they would have done a cutoff wall pack, you wouldn't have all of this light throwing up. And because like beyond where this photo shows, you're going to have a parking lot that has pole lights that are also throwing light. So it's like you have light bleed from the wall packs that are throwing it kind of to the middle of nowhere that you don't necessarily need because you have pole lights that are illuminating that other side. And it's like there are so many new construction buildings where they like an electrical contractor just says, hey, I need these lights and doesn't think anything of it. Whereas like it's just throwing a bunch of uplight. It's not useful. And it just kind of, I don't know, it drives me nuts. But Next one. So the city of Minneapolis. So I don't know if any of you have seen the purple lights. This is not intentional. The city of Minneapolis purchased 400 brand new LEDs from Cooper Lighting, and in the first 6 months, the electrical component that's supposed to provide white light um, just failed, and the whatever component that failed has caused all of these lights to turn purple. And it's like, and that's at the municipal level where it's like they're playing the game of I want it for the cheapest possible cost, where it's like, all right, well, this is what you get. And like I remember the city of Woodbury um ran an article on it because, and I guess this is the city of Minneapolis, but like this is happening all over the US because of, I guess we'll call it a faulty batch of manufactured LED, where it's like, all right, like somebody at the government needs to speak with someone who is a lighting expert so that stuff like this doesn't happen. All right. That's my spiel. I could go on for a while, but I guess questions, comments, any projects you guys are working on that you may have questions, and I'll exit out of this and just kind of go to um, full view. Or is there a way that I like? Is there a way that I could make it more palatable, easier to understand? The kind of the goal, and I guess the knowledge base that I have in lighting, there's certain things where it only comes out unless someone asks me a very specific question. And like I remember it early in my career when I was sitting down with the law office, and I'm like sitting in their boardroom with lawyers, and one of them stops me and goes, "This may be a dumb question, but what is Kelvin temperature?" And I was like, "Not a dumb question, not a thing that most people know." And like, she's a lawyer, so like I kind of gave the verbatim explanation. She's like, "All right, got it. Sweet."
I'll ask a question, Ryan. On the on the slides we had up with that, it said 5 years. Is that 5 year guaranteed life expectancy? 5 year, 5% of the lot has that life expectancy. 95% of the lot has that life expectancy. What is that? What does that 5 year work? And is that like EPA mileage, where it's like, a wild guess from
I
some
wouldn't call it a
theoretical
wild
table?
guess. The the scientists in the lab run um, pretty rigorous testing, but it in certain applications, if an LED is going to fail, it's going to fail in that first year. But there are definitely applications that were Gen 1 LED that got installed in 2015 in some of the churches that we're working with, where that system's still running, and it's into the 10-year span. And like on, I think on the spec sheet that I showed, it had a 5-year warranty. That warranty is huge. It's like with the reputable brands that are selling LED, if it has a 5-year warranty and your product fails 2 years in, you take a picture of the thing, you send it to them, they drop ship you a new fixture for like in kind of the in 2017, 2018, manufacturers started providing a 10-year warranty, and the people that were providing a 10-year warranty were new lighting contractors that wanted to get in on the LED boom, who hadn't been in business for 10 years. So it's like, how are you providing a warranty that's longer than you guys are in business? But um, yeah, the run hours on the tubes are pretty good. And like generally like an LED tube, if I'm like it generally lasts 2 or 3 times as long as a fluorescent tube. Because there was a long time where they were saying these are gonna last forever. It's like, well, no, they're not. Like, and like in
So
certain applications, like heat is a big thing where if you install tubes in a bakery and the bakery's ambient temperature in the ceiling is 140 degrees, you're going to burn those LED bulbs out. And like there's certain like mining applications where it's too hot, it's too wet, it's too rigorous, where you're just going to install metal halide because that worked for 75 years.
Hey, Ryan, this is Don. We're looking at doing a gym replacement. I think we have T8s up there right now. And you talked about, just having the one strip on the tubes. So, what do we need to watch out for? Is there a certain tube to get put in there?
So a 4-foot type B LED tube is basically exactly what you need. And if you have the tube quantity, I can run the numbers on what the energy savings would be. It's like there's type A, type B, and type C tubes. Type A work off the existing ballast. Type B require the fixture to be rewired. And then type C is an LED driver with basically a type B tube. And type B is the best. Once you rewire that fixture and it can just take a type B LED tube, when those LED tubes fail 5 to 7 years from now, instead of rewiring the fixture or taking the fixture down, throwing it away, you just order a handful of cases of tubes and relamp the fixture the same way that it had been done pre-LED.
Yeah, we were going to take the ballast and all that stuff out and rewire them. So,
Yep.
So it'd be type B then for us to do.
Yeah.
Okay.
Yep.
Ryan, this is Ken with Our Savior's Church. What information can you give me on a triac system? I've got bids from Premier Lighting to retrofit the clouds, the pendants, and the PAR 56s, I think, but they can't assure me it's going to work with our dimming system.
Yes, that is a game that I've played a handful of times where ideally you can get a sample to figure out if it works, but on dimming systems it's a tricky game of matching that existing system. I wish that I had a better answer for you.
I checked, I can't get one electrician said I could get new boards put in, but that's not possible. Can't buy them.
Yeah.
But we're concerned if we put them in, if they at least turn on, don't burn them out. So I haven't found the clear information that satisfies our console on that, but
yeah, dimmings or like matching existing sanctuary dimming systems is always it's like the most complicated game that you can play because a lot of the times, like if the sanctuary was built between 1995 and 2010, you may have a state-of-the-art fluorescent dimming system that has been phased out, and then when you install the LED, there's a remote dimming module where you need to potentially match a new module. When you go to LED, there's a load reduction. And so that load reduction sometimes causes flickering. And so you may need to add another module to combine all the dimming onto one dimming panel. And it gets tricky. And it's always expensive.
well, we've converted 2 of them, the cloud and the pendants, and they've been working, just one of each. But we haven't tried what we call the stage lights yet.
Yeah. Yeah, and with Light Cloud, so the industry is moving more towards brand new fixtures that are Wi-Fi enabled, where you can adjust it from an iPad or whatever, where it's all wireless. But that option kind of takes out the ability to retrofit, and it just kind of depends on the aesthetic. It's like if the congregation is okay with moving forward with replacing the pendants and going brand new fixtures, that works.
Yeah, we've got a quote for brand new pendants and we could retrofit the clouds, but so we tried two of them, so you think that we could go forward with that probably, huh?
Yeah. And like if you have the bids and you want to send them to me, I can kind of look through and see what I can piece together.
Okay, I've got two bids. Yeah, I could, I got your email. I can email them to you. Be okay?
Yeah. Yeah.
And give me some insight because I know very little about it, so. Other than it may not work. So, okay, thank you.
Yeah. Gotcha. If there's nothing else, I can sign off, and then this will be available on our website, I would imagine, end of week, and then we'll send out another newsletter that says if you missed it, here you go.
Well, I was unable to sign in time for some reason, but so I got in late, so. But I got the
No
sanctuary
worries.
card anyhow, that was very good. So it'd be good if I could review it again.
Yeah. Yeah, just reach out if you have questions.
Thank
Thanks,
you very
Ryan.
much.
Awesome. Thank you all.
Oh, I guess to sign off.